Today we're talking about torque. It's this invisible force that's literally holding our world together, from the smallest bolt to the biggest, baddest machines out there. So to really get a feel for this, let's start with a pretty intense question. Picture a jet engine. You've got these massive blades spinning at something like 3,000 RPM. What's the one thing that keeps them from just flying apart?
The answer? Well, it's actually simpler than you might think, but it's also absolutely critical. It all boils down to one thing: a precisely measured twisting force.
And that force, of course, is torque. Basically, it's a rotational force. If you push or pull something, that's a linear force. Torque is the twist. It's what makes things turn. But here's the kicker. Just applying torque isn't enough. Applying it correctly, well, that changes everything.
So that brings us to our first section. We're going to talk about the 7 rules for accuracy, because getting torque right isn't just a suggestion, it's a science. And if you break these rules, things can go very, very wrong. Let's look at some common mistakes and, more importantly, how to avoid them. Okay, mistake number 1, and this is a big one: using an uncalibrated tool. Think about it. Over time, with all that use, a torque wrench just naturally drifts from its factory settings. So setting up a routine calibration schedule, that's not just a good idea, it's an absolute must for getting accurate results. All right, next up, good old human error. You can have the most perfectly calibrated tool in the world, but if you're over-tightening or under-tightening a bolt, it's all for nothing. That's where proper training comes in. You've got to know the technique and follow those manufacturer specs to the letter. Now, this next one might sound a lot like the first rule, but there's a key difference: consistency. So many people will calibrate their tools once and then just forget about it. The rule is to stick to the manufacturer-recommended schedule and use certified services, like those following ISO 17025. That's how you know your tools stay accurate. And here's a simple one: using the wrong tool for the job. You wouldn't use a sledgehammer to hang a picture frame, right? Same principle applies here. Torque wrenches aren't one size fits all. You have to pick the right one based on the load and how precise you need to be. Number 5 is all about paying attention. Tools get beat up, they get dropped, they just wear out. So failing to spot that wear and tear is a huge mistake. A quick visual inspection can save you a world of trouble. If a tool looks damaged, you can bet it's inaccurate. It's gotta go. You know what else can mess with your tools? The environment itself. Things like extreme heat, humidity, even just dust, they can quietly sabotage the accuracy of your wrench. So the rule is simple: store your tools in a clean, climate-controlled spot. It protects them and makes sure they're reliable when you need them. And that brings us to the final rule. It's the old saying, trust but verify. Especially for really critical jobs, you can't just tighten a bolt and assume it's perfect. You need a double-check process. Maybe use a second tool to confirm the measurement. Think of it as your ultimate safety net. Okay, so we've been talking about precision at this really small scale, right? Like a single bolt. But now we're going to zoom out. We're going to make a big pivot from the wrench to the race car. So far, it's all been about applying torque correctly. But what if? What if torque could tell a much bigger story? What if we could use it not just to build things, but to understand them? So you might be looking at this and thinking, what does a simple wrench have to do with how a car accelerates? Well, it turns out they're basically 2 sides of the same coin. The twisting force, the torque, that an engine puts out is directly tied to how fast that car can get up and go. And this leads us to a really cool idea, a concept that's all about creating what you could call a car's performance fingerprint. And it all comes back to understanding torque. As Jared Kunanapadal points out, a car's performance isn't just about the engine. You've got the transmission, the tires, aerodynamics, friction, a whole bunch of things all working at once. So the real question is, how do you measure the final result of all that complexity? Well, normally you need this super expensive piece of equipment called a dynamometer. But the big idea here is way cooler. Instead of taking the car to the lab, you use the car as the lab. You can tap right into the car's own computer network, its CAN bus, and pull the data you need in real time while it's actually on the road. So here's how it works. First, you have to figure out the engine's raw power. This graph here, that's the engine's torque curve. It shows you exactly how much twisting force the engine is making at every different speed. This is step 1, understanding the source of the power. And then you get this. This is the payoff. You take that engine torque, and then you factor in all the things fighting against it: air resistance, friction, all that stuff. What you're left with is the car's actual acceleration on the road. It is, literally, its unique performance fingerprint. And the advantages here are huge, right? It's way cheaper because you don't need that expensive dynamometer. It's easier since you're just using the car's own sensors. And it's super convenient. You can see the results pop up right on a laptop or your phone. Okay, so let's tie all of this together. Our final section, the power of precision. Think about where we started. We were talking about the tiny, precise amount of torque on a single bolt. And we ended up talking about the overall performance of an entire car. The one thing connecting them? Torque. It doesn't matter if you're applying it or measuring it. Understanding this force is the key. It's how you unlock everything from safety to performance. And that really leaves us with one final thought. We just saw how being super precise on a small scale can completely change how we understand things on a massive scale. It really makes you wonder, doesn't it? With all the technology we have now, what's next? What other invisible forces are we about to understand in a whole new way?